Welcome to the DIY Honda Garage channel. The diagnostic trouble code DTC P0235-1C indicates an abnormality with the turbocharger boost sensor. This crucial component measures the boost pressure from the turbocharger and communicates it to the powertrain control module, PCM. If the sensor's output voltage is outside predefined parameters, the PCM registers an error, leading to the triggering of this DTC. The PCM plays a critical role in managing engine performance by interpreting signals from various sensors, including the turbocharger boost sensor. When the DTC is stored, it suggests potential issues that may affect engine efficiency, power delivery, or emissions control. Thus, it is essential to resolve this concern to ensure optimal performance and compliance with emission standards. The turbocharger boost sensor is located near the turbocharger and is responsible for measuring the boost pressure it generates. This sensor provides vital input to the PCM, allowing it to adjust fuel delivery and ignition timing accordingly. When the boost pressure exceeds or falls below operational thresholds, the sensor's output voltage may also be affected, leading to the DTC being set. If the PCM detects that the sensor voltage is below 0.72 volts, it interprets this as a malfunction, necessitating further investigation. It's crucial to inspect this component to ensure the engine operates within optimal parameters, maintaining both performance and efficiency. The functionality of the turbocharger significantly influences overall engine responsiveness and performance. Several potential causes can lead to the activation of DTC P0235-1C. One common issue is a faulty turbocharger boost sensor, which may have degraded due to age or exposure to harsh engine conditions. Another possibility involves problems with the wiring, such as shorts or open circuits, affecting the signal between the sensor and the PCM. Additionally, a malfunctioning PCM can also trigger this code if it fails to interpret the sensor signals correctly. Each of these components plays a pivotal role in the overall engine performance. Therefore, meticulous inspection and testing of these elements are essential in accurately diagnosing the root of the problem. When DTC P0235-1C is present, several symptoms may manifest, indicating issues with the turbocharger boost system. A noticeable decrease in engine power is often reported, which can negatively affect acceleration and overall drivability. Alongside this, poor fuel efficiency may be observed as the engine struggles to operate under optimal conditions. The most apparent symptom is the illumination of the check engine light on the dashboard, which prompts the driver to seek diagnostic assistance. Ignoring these symptoms can result in further complications, including increased wear and tear on components or potential engine performance degradation. Prompt diagnosis and resolution are crucial to maintaining vehicular integrity and performance. The first step in troubleshooting DTC P0235-1C involves turning the vehicle to the on mode without starting the engine. This prepares the vehicle for diagnostic testing. After the vehicle has reached this state, the next action is to check the HDS, or Honda Diagnostic System, for the TC boost pressure sensor value. If the reading is less than 0.72 volts, it indicates that the failure has been duplicated, confirming that there is indeed a problem with the boost sensor or its related circuitry. This initial procedure is essential as it helps to establish whether the issue is a direct result of the boost sensor, paving the way for more in-depth troubleshooting to follow. The second step in the troubleshooting process requires the technician to disconnect the turbocharger boost sensor connector, which typically has 3 pins. Once this connector is removed, the technician needs to inspect the output voltage of the sensor while keeping the vehicle in the IG mode. The expectation here is to measure a voltage output of approximately 5.0 volts. Achieving this indicates that the sensor circuitry is functioning correctly. If the voltage falls below this level, it signals a potential fault within the turbocharger boost sensor itself, warranting further inspection or replacement of this component. It's crucial to distinguish between sensor failure and related circuit problems during this evaluation. Following the check of the boost sensor, the next troubleshooting step involves inspecting the VCC2 power supply and the P3 signal wiring. Before proceeding, the technician must disconnect both the turbocharger boost sensor connector and the PCM, specifically the PCM connector B. Once the disconnection is complete, the technician can assess for any possible open circuits by measuring the resistance across the VCC2 circuit. Normal conditions would show a resistance of less than 1 ohm. Furthermore, the P3 signal circuit should be checked for shorts to ground, where normal conditions should exhibit resistance higher than 1 ohm. These checks are critical to rule out wiring issues before concluding that the problem lies within the turbocharger boost sensor or PCM. The final step of the troubleshooting process focuses on the PCM itself. If previous steps indicated that all related components, including the turbocharger boost sensor and wiring, are functioning correctly, this raises the possibility of PCM malfunction. This step is crucial, as replacing the PCM can be expensive. Hence, it should only be considered after all other components have been tested and ruled out. Typically, if the other inspections yield normal conditions, it can be confirmed that the PCM may indeed be the cause of the error. This step emphasizes the importance of a systematic approach to diagnostics, ensuring that all potential issues are explored before replacing major components. After completing repairs or component replacements based on earlier diagnostic steps, it's essential to clear any stored DTCs from the PCM using the HDS. Following the clearance, performing a test drive is necessary to observe the vehicle's performance under normal driving conditions. This allows the technician to confirm that the repair was successful and that the boost sensor is operating within the specified range without triggering any DTCs. After the test drive, checking the HDS again for any new errors or persistent codes is a best practice to ensure that the issue has been resolved effectively. This verification step safeguards the quality of the repair and enhances overall vehicle reliability. Preventive maintenance is key in avoiding future issues related to the turbocharger boost sensor. Regularly scheduled inspections of the sensor and its associated wiring can help catch potential problems before they escalate into serious DTCs like P0235-1C. Technicians should monitor performance metrics associated with the turbocharger to ensure that optimal boost levels are maintained. This includes checking for unusual engine behavior or efficiency drops, which could signal an impending failure. Additionally, keeping the connections clean and free from corrosion is important. Ensuring that all components work in harmony contributes to the longevity and reliability of the engine's performance. In summary, understanding DTC P0235-1C is vital for maintaining the efficiency and performance of Honda CR-V models from 2023 onward. This code highlights the importance of the turbocharger boost sensor and its role within the vehicle's engine management system. Performing thorough inspections on the sensor, wiring, and PCM is essential to accurately diagnose the problem. Addressing issues promptly when symptoms arise can prevent further complications and maintain optimal vehicle performance. By following a systematic troubleshooting approach and conducting regular maintenance, technicians can ensure a dependable and efficient driving experience for Honda CR-V owners. Please like and subscribe to the channel. See you next time.